We'll talk about forces. The word force in physics means exactly what it means in everyday language, exactly what you think it would mean. A very simple, very clear and understandable definition would be simply a push or a pull. Force is a push or a pull, and that's something we can all understand because we've all experienced that. Here's some examples. Lots of different things in the world are forces. So I'll just list a few different examples of things that are all very different, but all are pushes or pulls. Gravity is one, the force due to gravity. That's sometimes called weight. In fact, the definition of weight is simply the force on an object due to gravity. But it's a force. Gravity pulls you down toward the earth, and that pull downward is a force. Tension is a force. And by tension here, I mean the tension in a rope or a cable or a string, something like that. If you tie a rope to something and pull it, there's tension in the rope, and it's pulling at both ends. But that tension is a pull, it's a force. Lift, and in this case I'm referring to the lift generated by the airflow over an airplane wing. If you were to look at the cross section of an airplane wing from the side, it would look something like this. It's usually pretty flat on the bottom and curved on the top. So the airplane in this case is flying in this direction, and this is the leading edge of the wing here. And as the airplane moves through the air, you can think of it as the air flowing past the wing like this. And we'll talk about this in more detail later on. But just know that the shape of the wing causes it to generate lift upward as it moves through the air. And that's a force. And that's obviously one of the forces that helps an airplane stay up in the sky. Lift is a force. And friction is a force. We'll discuss friction later in this chapter. Friction is a force that tends to make things stop. It's a force that appears whenever one object slides against another. And friction always opposes the motion between two objects. And friction is a force. So all of these things, even though they're very different things, they're all can be thought of as a push or a pull. So all of these are forces. Force has direction, so it's a vector. Anything that has direction, remember, is a vector. And force has to have direction. You cannot push something without pushing it in a particular direction. So force is a vector. Now, we often use arrows to represent vectors because arrows, little arrows that we draw on the page, they inherently have a direction just like a vector does. So when drawing diagrams, it's useful to represent vectors with little arrows. And that's true with forces too. So let's draw an object here. This is some mass, and we'll draw a force pushing on it. So draw a little arrow here, and I'll call it F for force. Now, in many cases, it's useful to make a longer arrow to represent a stronger force. So if I were to draw this mass again over here, and I were to imagine pushing it twice as hard, I would draw an arrow twice as long. So we could call that 2F. If this is force F, then this is a force twice as much. And at least approximately, I've made this arrow about twice as long as that one. Force, one of the units for force would be pounds. So if you wanted to draw a force, for example, of 3 pounds pushing on an object, you could draw the little arrow, and you could write 3 pounds next to it. And you might want to put a little M on the mass. This just shows that a force of 3 pounds is pushing this mass in this direction. And following our earlier discussion, if you wanted to draw a bigger force, you could do a bigger arrow. So 6 pounds pushing mass M to the right.